Welcome back. All right, let's start a discussion on the Ice Age, shall we? I'm sure some of you have seen the Ice Age movies, animated movies. Yeah, there's some truth to that. So let's get into it, shall we? Um, we now know that the Pleistocene Epoch, which we kind of conveniently referred to as the Ice Age, was a time of several major episodes of glacial advances and retreats. So there was a few of these back and forth with glaciers. In addition, during times of glacial expansion, more precipitation fell in regions that are now dry, like the Sahara Desert or Death Valley, which supported streams, lakes, lush vegetation. Because again, the whole climate is changing. It's not just getting cold everywhere, it's getting cooler in places, but other things are changing about the climate as well. From certain glacial features, and we've touched on some of these in the past, from certain glacial features like moraines, erratic boulders, and glacial striations, we determined that the Pleistocene glaciers at the greatest were almost 2 miles thick. That's a lot of ice. That's a lot of ice to be moving around. So this image shows the maximum of extent, how far south, at least in North America, the glaciers moved during the Pleistocene. Kind of out in the west, it just barely kind of covered, across what is now the Canadian border. But over in the east, the Midwest and east, it kind of reached down into Nebraska, Illinois, Indiana, Ohio, New York, Massachusetts, on down. So it did reach in a pretty good ways. By mapping some of these deposits, like moraines and other things, we've determined that North America had at least 4 episodes of Pleistocene glaciation, and they're named the Wisconsin, Illinoisan, Kansan, and Nebraskan. And they're all named for the states where the southernmost glacial deposits, due to the glacier, are well exposed. That's where they got their names. In between glaciations, it's called interglacial periods. That's when the glaciers kind of retreated, and so we can see, layers of sediment that were deposited during glaciation, and then no glaciers, we might have plants and soil being created. Glaciers, no glaciers. Glaciers, no glaciers. So we can see these layers just like any other sediment or sedimentary rock. The climatic conditions leading to the Pleistocene glaciation were worldwide, but contrary to popular belief, and again, maybe the Ice Age movies are to blame there, Earth was not as cold everywhere, I should say, as commonly portrayed. I mean, it was cooler, for sure, but it's not like everywhere was just frozen. Not quite the case. In fact, evidence indicates that the world's climate cooled very gradually during the Pleistocene, and temperature did fluctuate as much as 18 degrees Fahrenheit, again, which is a lot. Right? It is a lot, but it's not like everywhere was freezing. There were still plenty of warm places, just not on the glaciers. During glacial growth, areas near those glaciers had very short, cool summers, long, wet winters. But if you were distant, you had varied climates. Some areas were still very warm, still very dry as well, just depending on where you're at. Ocean temperatures were cooler. That means less evaporation occurs. The warmer water is, the easier it is to evaporate up into the sky to become clouds and become rain. So if the oceans are cooler, well, that's going to reduce evaporation rate. So that's going to mean less moisture going into the air. That means less rain. So the world was kind of drier during these glacial maximums than at the minimums. So here's kind of present day. We still have some glaciers, obviously covering Canada, covering Greenland as well. So I'm just going to kind of flip back and forth. This is today. This is the greatest extent of the Pleistocene glaciers. This one during the Wisconsin glacial event. What I want to point out is, for instance, let's look at Florida. So if there's more ice, more water on land, that means less water in the ocean. So more land is exposed. So if I go back to present day, that means more water should be back in the ocean. Florida shouldn't be as wide. There you go. No glaciers. With glaciers, we're taking water out of the ocean. Right? But you can look at that almost anywhere, right? Look at how the coast extends almost everywhere. Almost everywhere. You pretty much get that. Almost everywhere. So these glaciers that are 2 miles thick are pretty heavy. So any glacier moving over a surface is really going to reshape that surface to give some distinctive landforms or get rid of some. As glaciers formed and eventually melted and wasted away, again, sea levels fell and rose back and forth depending on the glaciation, how much water was frozen, etc. Some of these glacial deposits are called moraines. I just wanted to talk about them a little bit more. The deposits of glaciers at the end of them they're called moraines. They're chaotic mixtures of very poorly sorted sediment deposited right at the edge of the glacier, by the glacier. Any moraine deposited at the end or terminus of a glacier is called an end moraine. However, there are different types of end moraines. Terminal and recessional moraines are types of end moraines. So let's take a gander here. This is the end of a glacier. This is the end, the terminus of the glacier. And all of this deposition here would be considered a terminal moraine. And then when we have the glacier retreating, right, and melting, it might stop for a period, continue to drop some sediment, move backwards, maybe drop some more sediment, move backwards, maybe drop some more sediment. And those are known as recessional moraines, deposits of glacial sediment as the glacier is recessing, moving backwards. Let's see here. Well, let me pause. I got to figure out where I'm at. Okay, got it figured out. So anywho, with these moraines, these deposits of sediment at the ends, the terminus of a glacier, there are terminal moraines as well as outwash. That's sediment that gets kind of melted out in little streams and flows away from a glacier. We can find these terminal moraines and outwash sediment in Ohio, Indiana, Illinois, and that really marks the greatest southerly extent of the Pleistocene glaciers in the mid-continent regions. There's also recessional moraines that indicate positions where the ice kind of stopped for a little bit, deposited sediment before it retreated further. So here's a map of the kind of Midwest that shows these moraines. So this darker, bolder dashed line, that's a terminal moraine, the kind of end of a particular glaciation extent of the deposits, sediments deposit from a particular glacier. And then the lighter dashed ones are recessional moraines. Kind of a little interesting story. So I'm from Cleveland, right? And so I knew about this, and so these ridges of sediment actually made like these different tiers as you kind of drive south away from the lake. And actually they use these moraine benches, these deposits of sediment. That's kind of where major roads kind of run along. This first one is probably Detroit Road. This one is North Ridge Road. And unbeknownst to most people, these different ridges are actually these moraines of sediment that were built up during the Pleistocene glaciation. We put some roads on there. Go figure. All right, let's go ahead and pause here. When we come back, we'll continue our discussion on the Ice Age. See you back here in a second.